Hello friends, welcome to Catalyst Chemistry. As we discussed last class, most important point Wurtz reaction, next one is what fatigue reaction, combination of these two Wurtz fatigue reaction. Wurtz reaction means there must be alkyl halide can react with a what sodium in the presence of ether to form a higher alkanes, that is called what Wurtz reaction. In fatigue reaction compulsory we are going to consider aryl halides. Aryl halides means for example chlorobenzene, bromobenzene, iodobenzene etc. Okay, that can react with what 2 moles of sodium, because this is also 2 moles of sodium in the presence of ether to form a biphenyl or a diphenyl. This is what fatigue reaction. Next one is what the Wurtz fatigue reaction. You have to take 1 mole of Rx that can react with the 2 moles of sodium, and next you have to take 1 mole of what aryl halide. Okay, there is a formation of product is that is called what toluene is there, benzene ring having a CH3. Okay, that is the product. Okay, up to this what we have discussed last class. Today we are going to discuss the most important point in PU board. They are going to ask you what board examination 2 to 3 marks questions. Okay, most important. The heading is very simple, reaction of what haloarenes. In this case answer is a very simple. Okay, answer is what very simple, just here reaction of haloarene. Haloarene means what benzene ring. Okay, benzene ring can connect with what any one of the halogen, usually chlorine, bromine, and next one is what iodine possible. Okay, in this case the nucleophilic substitution reaction. First bear in mind what is nucleophile and what is electrophile. Nucleophile is electron rich. You know, nucleophile is generally represented by what like this. The nucleophile is having a what electron rich center. Next one is what, this is a electrophile. Electrophile is having a electron poor. This point you must know. Okay, in this case what happens, the nucleophilic substitution reaction. Nucleophilic substitution reaction means we have to substitute nucleophile into the what benzene ring. Okay, that is what nucleophilic substitution reaction. Okay, that's why this is the most important. Nucleophile means what electron rich, electrophile is what electron poor. Okay, the nucleophilic substitution reaction, just here aryl halides. Aryl halides means what chlorobenzene, bromobenzene, iodobenzene. Aryl halides are extremely, most important point, extremely less reactive towards nucleophilic substitution reaction. Nucleophilic substitution reaction in PU board they are going to ask you directly this type of question. Similarity. Okay, similarity means what, they are going to ask you give reason. Aryl halides do not undergo, extremely do not undergo nucleophilic substitution reaction, give reason. They are going to ask you 2 to 3 marks question. In this case 4 reasons are there, you have to write 4. If they ask 2 marks you have to write 4, if they ask 3 marks you have to write for all the 4. Okay, reason, what are the reason means, the first one is resonance effect, the second one is hybridization of carbon atom, third one is what instability of what phenyl cation, fourth one is what high electron density on benzene ring. These 3 are what 4 reason. In PU board up to this is enough, up to this is enough means what they are going to ask you such kind of questions, you have to write this is the answer. Okay, this is what completed. In this case the next point, what is resonance effect, what is hybridization of carbon atom, what is instability of phenyl cation, next one is what high electron density on benzene ring. All these things we will study what just knowledge purpose. Just here I am going to explain one more thing. In this case what just I am going to ask you. Okay, here is there, I am going to consider one example. Okay, what is the name of this one? Chlorobenzene. This chlorobenzene do not undergo nucleophilic substitution reaction, give reason. Okay, this is a PU board question. Okay, in this case it may be bromine or iodine. Okay, I repeat, this chlorobenzene do not undergo nucleophilic substitution. Nucleophilic means what, in this case just I am going to consider what, you have to consider any one of the nucleophile. Okay, any one of the you have to consider nucleophile. Okay, this is just here, if Cn minus is there, okay, all are indicate what nucleophile. This nucleophile is not going to attack on ortho, meta and para position. This is not possible. This is what not possible. The reason is what, these 4 are what reason. Okay, in this case first we are going to study, that is what resonance effect we are going to study. Okay, just here in this case the first point is what resonance effect. In this case first one you have to take, the first one is what resonance effect. Resonance effect. Okay, in this case resonance effect means I am going to consider chlorobenzene. Chlorobenzene is a very good example. Just here 5 this is not possible. Okay, this is what benzene ring, this one is indicate what Cl. The name of this one is what chlorobenzene. This chlorobenzene do not undergo nucleophilic substitution reaction. Just here in this case what happened, this chlorobenzene is having a what lone pair of electron. Okay, lone pair of electron means what chlorine. Chlorine means atomic number what it will come under a what halogen family. Atomic number is what 17. If halogen family is there, the outermost electron or indicate what 7. Outermost electron or indicate 7 means 1, 2, 3, 4, 5, 6. Next one is what 7. This can combined with what benzene ring. Okay, this is the what fact. Okay, that's why in this case what 2, 4, next one is what 6 lone pairs are there. Okay, in this case, okay, according to what outermost electron. In this case what happens, this benzene ring is act as a electron withdrawing group. In this case, this benzene ring is act as a electron withdrawing group. This can donate a electron towards a benzene ring. Automatically what happen in this case, what resonance takes place. If you want, you can write like this also, no problem. Okay, like this. Just here in this case, this lone pair donate here, automatically what happen in this case, carbon oxygen double bond is going to what break. Carbon oxygen double bond is going to what break. There is a formation of what negative charge. Okay, that is important, bear in mind. Okay, negative charge is possible. Next, after that I am going to write resonance structure like this. In this case what happen, this is what benzene ring as it is, double bond as it is. In this case what happen, there is a formation of double bond. The Cl is going to get a positive charge. Why Cl is going to get a positive charge? Because valency of Cl is going to fail. What is the valency of Cl? Only one. If you want, you can write HCl is there, no? In this case, how many bonds are attached to Cl? Only one bond. That's why in this case what the Cl is going to get a 2 bonds. That's why valency is going to fail. That's why we are going to get a positive charge. Okay. Next, after that there is a formation of what negative charge. Okay. Next, after that what happens, this negative charge donate here, automatically this carbon double bond is going to break. At the para position there is a formation of what negative charge. You know very well about that ortho, para and meta position. Okay. If you want, you can check PUC first year video is there. Okay, in YouTube only. Okay, this is positive charge. Okay, the negative charge present on the what this is what negative charge present on the what para position. Next, after that the next resonance structure, this can donate here, automatically in this case what happened, the carbon double bond is going to break. Okay, there is a formation of product just here. In this case what we are going to write a negative charge, this is a double bond, here is what Cl, this is what positive charge. Okay, next, after that, next in this case you have to donate here, automatically in this case what happened, chlorine carbon double bond is going to break. Okay, there is a formation of final product. This is what final product. Totally how many resonance structures are possible? Total in this case what 5 resonance structures are possible. You have to count. Okay, finally the final product is possible means what, that is a resonance hybrid. The resonance hybrid structure is possible. For example, like this is going to get a positive charge like this. Okay, next, after that what Cl is there, no? This one is indicator what resonance, otherwise don't write a positive, you have to write like this. Okay, this one is indicate what a resonance hybrid structure. Okay, just here in this case what happen, all these are indicate what resonance effect of what chlorobenzene. In this case what happen, aryl halides are extremely less reactive towards a nucleophilic substitution reaction. Just here in this case I am going to consider a nucleophile. Okay, the nucleophile is a what electron rich. In this case the negative charge present on the what ortho and para position. Okay, this nucleophile is not going to attack on ortho and para position, only it attack on what meta position, like that only. Here is negative charge is there, here one is negative charge is there. In this case what happens, this negative start what repulsion, same charges is there, no, start what repulsion. Automatically in this case the nucleophile is not going to attack on what aryl halides. The nucleophile is not going to attack on what aryl halides, bear in mind. The first point is what completed, that is what resonance effect. Okay, most important, bear in mind. Okay, if you want to, you have to take here negative charge is there, in this case what ortho. Next, in this case if you want, you can take a nucleophile. Nucleophile is a electron rich, this is also electron rich. In this case what happen, automatically there is a start repulsion, there is a what start repulsion. That's why the nucleophilic substitution is not possible in what aryl halides. Okay, this is the point. Next, the resonance effect is what completed. Okay, the next second one, in PU board they are not going to ask write the mechanism of this chlorobenzene, all those things, just you have to practice these 4 reasons for that question. Okay, The next one is what? Second one. The second one is what? That is hybridization of what? Hybridization. This is also important. Hybridization of what? Carbon atom. Okay. Hybridization of what? Carbon atom. Just I am going to remove this one. Hybridization of what? Carbon atom. Okay. Just here, next important point. Hybridization of carbon atom means what? Just I am going to consider two example. Comparison is the most important while you are studying. Okay. I am going to consider one example for chlorobenzene, another example for what? Chlorobenzene means what? It will come on aryl halide. Another example I am going to consider alkyl halide. Just here, the first example I am going to consider here. This is a benzene ring attached with what? Chlorine. Okay, first example comparison. Next, after that I am going to consider R here CH2, that is I am going to write a carbon containing 2 hydrogen. Next one is what? Cl. These two examples are there. This first example do not undergo nucleophilic substitution reaction. You know, extremely less reactive. Okay, bear in mind. But this can undergo what? Nucleophilic substitution reaction. Next question, how it is possible? Just here, in this case with the help of hybridization, we can explain with the help of what? Hybridization. Just here, this chlorine attached to what? This carbon. Next, my question, what is the hybridization of this carbon? My question is what? What is hybridization of this carbon? If you want, you can write a double bond, okay, like this, no problem. Okay, you know very well about that trick. You have to apply that trick. Okay, I told in what PVC first year point is there. No, if you want, you can check in PVC first year video. Okay, no problem. Here is there carbon. This carbon containing how many sigma bonds? You have to count only sigma bond. Plus, if it is there negative charge and lone pair you have to count. Don't count pi bond. Okay, in this case, just you have to count how many sigma bonds are there. 3 sigma bond. 3 sigma bond. Is there any lone pair or negative charge? No. You have to take 0. Equal to what? 3. 100% hybridization is what? sp2, because 2p 1s, 2 plus 1 3. This is the trick. Okay, you have to apply this one. In this case, what is hybridization of this carbon? Hybridization of this carbon is what? sp2. Is it clear? Okay. If 4 is there, 4 plus 0, by chance 3 plus is there one lone pair equal to what? 4, that will go what? sp3. But in this case, not like that. Okay. Next, after that, my question is what? This one. What is the hybridization of this carbon? Now tell me how many sigma bonds are there? You have to count. Very simple. 1, 2, 3, 4. 4 sigma bond. 4 sigma bond. Is there any lone pair or a negative charge? No. That's why in this case 0, you are going to get a 4. Now tell me what is the hybridization of this one? sp3. 3 plus 1, 4. Okay. Case closed. Very simple. In this case, what? This carbon is having a what? sp3 hybridization. One is what? sp2, another one is what? sp3. This can undergo, this do not undergo nucleophilic substitution reaction. If it can undergo means what? That is extremely less, extremely what? Less. Okay, but this can undergo what? Nucleophilic substitution reaction. Next, my question, why this can undergo? What is the reason for hybridization? Just here, if sp2 is there, in this case what? S character is more. If S character is more, the electronegativity character is more. Indirectly, if the more S character, more electronegativity, you know very well that that concept. In this case, what is the S character percentage? 25%. If you want, you can write, no problem. S character percentage is what? 25. Don't worry about a P. You have to neglect P. What about a P? P is 75. 75 plus 25 equal to what? 100. In this case, what about S character? S character, I think it may be 33.33%. 33.33% S character. Out of these two, which is having a more S character? Obviously, this is having a what? More S character. If more S character means more electronegativity. More electronegativity means what? Just here. In this case, what? This carbon is having a more electronegativity compared to this carbon. This is a more electronegativity. Chlorine is also more electronegativity. In this case, what happened? There is a more attraction between this carbon and chlorine. This carbon and chlorine. There is a what? A much stronger bond. But in this case, not like that. This is a less S character. Cl will go out easily. But in this case, not like that. This is a one reason. This is a what? One reason. With the help of the S character, we are going to explain. The second reason is, in this case, this chlorine is having a what? Lone pair of electron. It can donate a lone pair of electron towards a benzene ring. There is a formation of possible double bond character. In this case, what? There is a formation of what? Possible double bond character. If there is a double bond character, it is very difficult to break. If double bond is there, it is very difficult to break, but if single bond is there, it can break very easily. That is why in this case what aryl halides do not undergo nucleophilic substitution reaction. This is also what another reason. These two reasons are most important. Bear in mind, one is what hybridization, another one is what double bond. But in this case not like that. Just here some of you are thinking about this chlorine is also having a lone pair of electron, it can donate towards this carbon. This is not possible, because in this case this R is a electron donating group, not a electron withdrawing group. But in this case benzene ring is act as a electron withdrawing group. Obviously the electron means lone pair of electron attract towards itself benzene. Okay, that is why in this case most important. Okay, hybridization of what carbon atom. Okay, with the help of the what hybridization of carbon atom, depends on what hybridization of carbon atom. If sp is there, sp2 is there, that will not undergo nucleophilic substitution reaction, but sp3 is there, that can undergo nucleophilic substitution reaction. Okay, these 2 points are clear. Okay, next another point is there, that is what instability of phenyl cation. Just here we are going to study about next point, that is what instability of phenyl cation. Okay, third one, no, instability. Instability means what? Just here, just I am going to consider chlorobenzene. Okay, chlorobenzene start donating its chlorine atom. Okay, third one is what? Instability of phenyl cation. If you want, you can write carbocation also, phenyl carbocation, no problem. Okay, just here I am going to consider, this is what chlorobenzene is there. Okay, this is what chlorobenzene. If you want, you can write double bond, because double bond is a better to explain in the mechanism and resonance. Okay, after that this can undergo, if you want you can change, no problem. Okay, this is what this chlorobenzene in the presence of what heat, if you are going to supply some amount of heat, there is a formation of product is what? Just here double bond is there, here double bond is there. In this case there is a possible of what? Positive charge, release of what? Cl minus. Just here this one is indicate what? Phenyl carbocation. This phenyl carbocation is unstable, that is why they called as a instability. Okay, that is why in this case what? Unstable, if you want you can note down, unstable carbocation. Okay, unstable carbocation. If such kind of unstable carbocation do not undergo nucleophilic substitution reaction. Okay, bear in mind, because of in this case what? This phenyl unstable carbocation is not resonance stabilized, bear in mind. That is why the incoming nucleophile is there, that is incoming nucleophile is what? Negative charge. In this case this negative charge is not going to attack on what? This unstable carbocation, unstable phenyl carbocation, because first of all this unstable phenyl carbocation is not a resonance stabilized. If nucleophile is going to attack, there must be a resonance stabilized, but that thing is not possible in this case. That is why the third reason also agree with what? In this case the last one is there, that is what? High electron density on benzene ring. Fourth one. Okay, fourth one, high electron density on benzene ring. Okay, high electron density on what? Benzene ring. Just here I am going to consider benzene ring. Okay, this one is what? Benzene ring. Just here I am going to tell you very important 2 points are there, very important. Okay, bear in mind, that is what? Compulsory. First I am going to explain this one, benzene ring, substituted benzene ring and benzene ring. Now differentiate between these two. I am going to consider another point is what? Substituted benzene ring. What is the meaning of substituted benzene ring? Means what? Any one of the group, it may be chlorine, bromine, iodine, or what? NO2 or CN, whatever it may be. Any of the one group directly attached to a benzene ring, that is what? Substituted benzene ring. Okay, this is what? Normal benzene ring. Out of these two, my question is, out of these two, which is the more reactive? Obviously what? Substituted benzene rings are more reactive compared to benzene ring. I repeat, substituted benzene rings are more reactive compared to what? Benzene ring. That is why majority of the reaction, you have to take any of the organic reactions, compulsory there must be what? Substituted. Benzene ring is having any one of the group. Okay. That is why that is most important. If you want, you can take up directly benzene ring, it can react with something you are not going to get. Okay, that is important. That is why high electron density on benzene ring. The reason is very simple in this case. You know, this is a benzene ring is there. I have a nucleophile here. Okay, the nucleophile is a electron rich. Just here, in this case, all the carbon also having a electron rich. Why electron rich? In this case, what resonance takes place? In this case, what resonance takes place? Benzene ring having a what? Resonance takes place. All the carbon having a electron rich. The incoming nucleophile is also electron rich. In this case also electron rich. In this case also electron rich. Obviously, in this case, what the start what? Repulsion. If there is a repulsion is there, that reaction is not possible. That is why high electron density on benzene ring, the electron density on the benzene ring is more. Okay, the incoming nucleophile is not going to attack on benzene ring. Okay, this is the fact. Okay, up to this, what these 4 reasons are most important. In examination, they are going to ask you only these 4 points. Don't worry about all these explanation and mechanism. They are not going to ask such kind of questions. Okay. Anyhow, up to this, what the reaction and some of the reasons are completed. The next thing we will study next video. Thank you. Subscribe and promote the channel, friends. Okay, thank you.